Okay, so I hope that you have this sheet of paper because it wasn't in the original package that I handed out. So it corresponds to section 6.2 in the textbook. And there's a whole bunch of formulas here that we're going through. And so if I just pop over to the formula sheet, you'll see that in one day here we're covering all this stuff over here, right? So all these things over here, we're going to be covering them all. And if you look at the title of our lesson, there's sort of three things happening. We're having sum. So what are sums? That's when you add. We have differences. That's when you're subtracting. And then we have double. And what does double mean? It's like times 2. So wouldn't be too hard to figure out. Let's erase a bit of my mess here. There's my eraser. So if we can figure out that these are going to be the differences. So look at the subtraction, right? So these are going to be the difference when I can find the difference between two angles. And now this symbol here, that's the Greek symbol, Greek letter, the first Greek letter of the alphabet. It's the alpha. And this one here is a beta. It's just the second Greek letter. So it's just like we've been using theta all the time. And in algebra, we use x, y, and whatever letter we want. In angles, the tradition is that we use these Greek letters. And so it could just as easily be A and B or any two letters, but we like to use these ones. They feel kind of cool. This is not a difference now. This is going to be the sum. And these are the double. Okay, so you can see the double. Alright, and so we'll start to recognize some of the patterns in there, but the nice thing is they are on the formula sheet. We do not have to memorize them, so it's all good. So this is for your benefit and for our easy reference, we put them in there. Okay, let's take a look at the first example here. It says, simplify the following expressions and give the exact value. So let's look at this, and I've got and that would be my alpha, and this would be my beta. Okay, this my first angle is pi over 3. My second angle is pi over 12. And so now let's look for this pattern. Cos times cos plus sine times sine. So which of these does it look like? So cos times cos plus sine times sine. And you'll notice that the alpha and the beta stay in the same order. So it's cos cos plus sine sine. So it's literally looking up the pattern and seeing it. So in other words, which one was it? It was the cos difference. So it's cos alpha minus beta. So it's going to be equal to the cos. Now alpha is pi over 3. Minus the beta, which was pi over 12. Okay, so that's going to be the same thing as, well, what is pi over 3 minus pi over 12? That's going to be the same thing as 4 pi over 12 minus 1 pi over 12. Right? Because here, to make this the same denominator, I had to multiply the top and the bottom by 4 in this one. So that's where I got my 4 pi over 12. And so this will be equal to the cos of 3 pi over 12. And 3 pi over 12 is the same thing as pi over 4. Cos of pi over 4. Finally, we can apply our trig part here. And the cos of pi over 4 is root 2 over 2. Okay, so there's my final answer. Okay, so let's take a look at this one. Cos squared of 47 degrees plus the sine squared of 47 degrees. I could spend some time trying to look for this pattern, but it's just to remind you this one. It's not this pattern here, is it? Because that is cos squared minus sine squared, and this is cos squared plus squared. So in fact, this is actually from a previous unit. This is a Pythagorean identity that we're going to use, and we're going to just say right away, boom, it's equal to 1. Kind of neat. We're done, okay? But let's say we were to change this question, okay? Just for fun, let's go and change this question. So I'm going to erase my answer here, and let's say that it was not a Pythagorean, and that it was indeed a subtraction here. So I'm going to ixnay on the plus. Okay, so let's say it's cos squared minus sine squared. So how would we solve that question? It's pretty close. Oh, it actually is exactly this, right? Cos squared alpha minus sine squared alpha. So in this case, alpha is equal to 47 degrees. We don't have to do any playing around. So my answer will be cos of 2 times 47 degrees. 2 times 47 degrees, which would be equal to the cos of 94 degrees. And I've changed the question, and so I really can't solve it. I can't figure out the exact value. Okay, I would have to get my calculator out and plug in 94 degrees, so whatever that would be. So I played around with it, and it should be plus, because then we can get an exact value of 1. If it's minus, we can actually figure out use that double angle identity to solve it, but we would not get an exact value. Okay, the last one, 1 minus 2 times the sine squared of pi over 8. Can we find that pattern somewhere? In fact, here is the pattern right there. Here's the 1 minus 2, right? So when we're comparing those, we can see pretty clearly that alpha is equal to pi over 8, and we're going to say that's equal to the cos of 2 times pi over 8, which is pi over 4, which is still root 2 over 2. Okay, so that is a little bit of an introduction of how these work. It says here we can use these formulas to determine the exact value of a trig ratio that is not on the unit circle. So we know the exact values when we're thinking about all those ones that we memorized in the previous chapter, right? We knew pi over 6, right? And all the multiples of this, right? Pi over 3 and so on. And we also knew the multiples of pi over 4. And sometimes those overlap, but essentially when you think about all those things that we learned on the unit circle, they were all multiples of pi over 6 and pi over 4. So we had, pi over 6 here, and the next one was pi over 4, and the next one was pi over 3, which is just really 2 of these, right? 2 pi over 6s. And then we had pi over 2, which is just really 2 of these. So when you think of that. So what we can do here is we can say I'm going to use either the sum or the differences. So I'm going to use something from this category here, and I'm going to pick 2 angles that I know the exact values for, so that when I either subtract or I add, so I get 7 pi over 12 in our question, right? So if I'm looking at this, first of all, I should translate this and say, well, pi over 6 is equal to how many over 12? 2 pi over 12. See if I can make those better. Pi over 4 is equal to 3 pi over 12. Okay, and we could even keep on going. We could say, oh, what about pi over 3 and pi over 2 and so on. But one method of looking at these questions and just say, how many of these would I need, and how many of these do I need, and I can add or subtract. So I'm looking at how do I, using 2's and 3's, how do I make a 7? Okay, so I could say, well, 2 plus 3, I could use 2 of these, right? 2 of those and 1 of those, and then add them together. Okay, so in other words, what I'm thinking is I could take 2 pi over 6's plus 1 pi over 4. Or in other words, I could do pi over 3 plus pi over 4. Okay, and just to think of this in terms of twelfths again, so just as a reminder, that's the same thing as 4 pi over 12 plus 3 pi over 12. Right, where this is 4 pi over 12 and this is 3 pi over 12, and that adds up. Okay, so my next line over here, that was my thinking space over there. So back over here, I'm going to say that sine of 7 pi over 12 is equal to the sine of, now this is where I'm going to break it up, and I'll say 4 pi over 12 plus 3 pi over 12, which is equal to the sine of pi over 3 plus pi over 4. Now is the time to go look at our formula for sine and adding. So I'm looking over here. Here's the sine and adding, or the sum. Okay, so I want to copy this sine alpha cos beta plus cos alpha sine beta. So you'll notice something. They keep the order of the alpha and the beta the same, but they switch the order of the cos and the sine. Okay, so I will have to go over here and I'll have to write that out. I have to sort of remember it. So I will get the sine times the cos, and this is pi over 3 times pi over 4 plus, now they switch this, cos of pi over 3 plus the sine pi over 4. So I hope I got that right. And then we have to know what each of our values are. Did I get, yeah, okay, so the sine of pi over 3, so where is pi over 3? Pi over 3 is up here. Okay, and so for pi over 3, my x value is a half, so my cos is half, and my sine is root 3 over 2. And my other one is pi over 4, where it's root 2 over 2 and root 2 over 2. Okay, so my sine of pi over 3 would be equal to, this is my pi over 3, and this is my sine, so it's root 3 over 2. Oh, I suddenly got a little thick one there. The cos of pi over 4 is root 2 over 2, plus the cosine of pi over 3, which is my x value over here. That's going to be equal to a half. And then multiply, oh, I did a plus here, so it should be times the root 2 over 2. So here I will get root 3 times root 2 is equal to root 6 over 2 plus root, oh sorry, made a mistake, root 6 over 4. So remember multiplying of fractions, numerator times numerator, and root 3 times root 2 is root 6, 2 times 2 is 4, and over here 1 times root 2 is root 2 over 4. Now best to put it into one fraction. So we already have the denominators the same, so the best way to write this is root 6 plus root 2 all over 4. So there would be your answer. Okay. So this part here, this whole zone off to the right, that was just sort of my thinking. Okay, that might be on your scrap paper or off to the side. These are the steps that you actually did to show your work. Okay, so now we're asking to find the cos of 195 degrees. So we switch from thinking in radians to thinking in degrees. Okay, so remember I had said that what it boils down to is that we know the multiples of pi over 6 and the multiples of pi over 4. So another way to think of this is that pi over 6 is equal to 30 degrees, and this is equal to 45 degrees. So how are we going to figure out 195 in terms of 30s and 45s? Sometimes it helps to think about where it is. Okay, so 195 is going to be 180 plus another 15. Right? So it's going to be 180 and then an extra 15 over there. That's 195 degrees. So how could we make that? Well, it seems to me that you're going to need one of these 45s, right? So because it ends in a 5. So if I do 195 minus 45, I get 150. And then I can have 5 of those, right? Does that make sense? So I need to get 150 degrees and 45 degrees. So my next step over here, I can say it's going to be the cos of 150 degrees plus 45 degrees. Depending on how you think better for figuring out these exact values, I find if I'm thinking about, okay, what does 150 degrees look like? 150 degrees is, it's over here, right? It's 30 degrees off of that. So the reference angle here is pi over 6, and this one over here is 5 pi over 6. Okay, so you may just want to go and think in your head, okay, this is the same thing as 5 pi over 6. And this one over here, of course, is pi over 4. Okay, so then we're going to follow that same pattern. We're going to look for the cos addition. So looking over here, the cos addition, so a new color. This time we're using this one here. So we want to do the cos minus sine pattern. I feel like switching to green here, so we're going to do the cos 45 degrees, cos, oh, you know what, I may as well keep the same order, it doesn't really matter too much, but if I wrote 150 first here, I may as well do 150 first here too. So okay, it's cos of 150 degrees times the cos of 45 degrees, and then it's minus the sine of 150 degrees times the sine of 45 degrees. Or alternatively, you could do this whole in 5 pi over 6, pi over 4, and then the same thing over here. This would be 5 pi over 6, pi over 4. Yeah, you know what? Since I switched to radians, maybe I should have just kept in radians. What is the cos of 150 degrees? So remember that our reference angle here for 5 pi over 6 is pi over 3. My cos for that one is root 3 over 2. And so in 5 pi over 6 is going to be negative root 3 over 2. So here I will get negative root 3 over 2 multiplied by the cos of 45 degrees, which is root 2 over 2, minus, now my sine of 150 degrees is going to be negative 1/2. And then the sine of 45 degrees is root 2 over 2. So be careful of your signs. Same thing now when we're multiplying. I'm going to have root 3 times root 2 is going to give you, in this case, negative root 6 over 4. I'm subtracting something that's negative, so I'm really going to be adding here, and I'm going to get root 2 over 4. And so my final answer here will be negative root 6 plus 2 all over 4. Okay. Oh, you know what? I did make an error here. Just looking over my work, here's my error. The sine of 150 is actually positive. Here's my error. This should be positive 1/2. So, and I was just saying, watch your positives and negatives. So that should be minus, and then this one over here should be minus 2. Oh, that was neat. And there's your answer with a square root sign over top. Negative root 6 minus root 2. I'm going to pause there.